Welcome to the first practical of machine learning here from laboratory practice 3. That's implementation of linear regression example by using the Python programming language here. Let's see the first problem statement here, assignment on linear regression. The following table shows the result of recently conducted study on the correlation of number of hours spent driving with the risk score of developing acute backache. Find the equation of base fit line for this data. You just can find this table. The number of hours spent driving here, these values are given, and the risk score on the scale from 0 to 100. So just we have to form a relationship between these two kind of variables. When x is the input, y is the output. So before proceeding, we'll see some theoretical concepts here. What exactly the meaning of regression is. Regression analysis is a very widely used statistical tool to establish relationship model between two variables. One of these variable is called as predictor variable, and whose value is gathered through various experiments. The other variable is called response variable, whose value is derived from the predictor variable. Okay, if you compare this is your predictor variable and this one is your response variable. Okay, so we have to train your algorithm, linear regression algorithm, with these values, and based on that we have to find an equation that will best fit for this kind of the data here. Okay, so there are four kind of regression applicable: linear, multiple linear, logistic, and polynomial. So out of four, we'll be using the linear regression to train our model for the given data sets here. So how exactly linear regression is there? In linear regression, these two variables are related through an equation where exponent of these two, the power of these two variables, is 1. Mathematically, linear relationship presents a straight line when plotted as a graph. A non-linear equation, exponent of any variable not equal to 1 creates a curve. Okay, so the general mathematical equation for linear regression is y is equal to x plus b, as we all know. So y is the response variable and x is the predictor variable. Okay, basically y is output variable and x is the input variable to it, and a and b are called as coefficient. Generally, if you compare the Python's linear regression class, b is called as intercept and a is called as the coefficients, whose value we have to calculate, and based on that we have to form this equation when value of x is given as input to it. There are two kind of linear regressions available: positive and the negative linear relationship. So in positive, when value of x is increasing, y is also increasing, but just inverse of that, when value of either x or y is increasing, okay, so other one will be decreasing, but they are linearly connected. Okay, so the example given here, it comes under this category, positive linear relationship. What are the applications of it? So some of the applications like trend lines, when GDP, oil prices are changing according to the time. So economics also, in finance also we can use this, the risk of investment to find. Biology, when your relationship between multiple biological parameters can be created with the help of the linear regressions. Now let's come to the coding. So to do this task, we need some packages to be installed in my system. Pandas is for data analytics. I'm using CSV file import here to do this one. I need pandas package. NumPy, numerical computing, so I'm using the NumPy array here to store the data of x and y, because core Python does not support the concept of array, that is the collection of similar kind of elements. List is supported, but list is not intended to store the similar kind of data elements in it. Third one, that is matplotlib.pyplot, just to plot the graphs. That also will going to view or visualize your linear regressions relationship with the help of the plots. The last, that is sklearn, where the linear regression classes are stored, and we need to create object of it, and then we'll apply your data set to the given object and train your algorithm based on the given data. Some steps, just an example I've given here. For example, height and weight, two values are there, they're connected by a linear regression. So if you create an equation for them, we have a relationship between height and weight of the person. So we'll carry out some experiments gathering sample of observed values of height and corresponding weight. Then we create an object of linear regression class. Then we train the algorithm with the fit function basically. Then we'll find some summary relationship, average as well as average error in the prediction, that's called as residuals. And to predict the height, weight of a new person, we use the predict function to perform these operations. Okay, so these are the few steps. Now come to our problem statements. For this case, our paint is the input variable and the score is the output variable. So we have to form a perfect relationship between these two. So whatever steps given in the previous example, that will carry forward in a Python program to generate our outputs. So let's continue. I've just written that code here and we'll see the operation step by step. First, import all the packages, NumPy, matplotlib and pandas. We are given some aliases to them, so to shorten the names of them. And then I'm reading the CSV file, which is hours.csv. Let's see this file. So it's saved here. It's the name. Here is hours1.csv here. Okay. See, this data I've saved in a CSV format, that is comma separate values format. So just close this. And now we'll import all. Okay, it's Python's terminal. Done. Then I'll read my data set. Check it out. I'm reading this data set by pd.read_csv hours.csv. Okay, actually my data set name is hours1.csv. This is x, y. Let's see. This one, x is equal to dataset.iloc. So what it does, it takes all the rows from the data set except the last, that is input variable is the first column, and with the last, that is the output variable. If you see the data set, see, first paint and score, they are red, and x and y are separated. See, these are the array format. X is the first column and y is the second column which you have taken, because we have to assign these values separately to the linear regression class. So let's continue. Now import the class from sklearn.linear regression model, linear model. This is one of the sub package from which we are importing the linear regression class here, and then we are going to create the object of it. Create the object. Generally we follow the name regressor to create the object of linear regression here. Here the parameters are not compulsory because we are creating a basic linear regression object over here. Then we train your algorithm based on this data, that is x will be the input, y is the output, and fit function used to train the algorithm, linear regression algorithm, with x as input and y as the output. So it will be trained and it will create the value of coefficient and intercept. If you see this, see, I just print the value of coefficients. This is the value of coefficient created, and this is the value of intercept created. So this is the value of a, this is the value of y. Okay, done. And now let's see how much accurately the given algorithm is fitted to the data set. 43.70. Okay, score function finds it, input is x and y into 100, and that's not good because the data is not actually linear. So linear regression is not a suitable algorithm to feed that particular data. It shows 43.70 for the original data set. Even we can modify to make it more linear, and so that your accuracy will be more. Let's see. So a simple example I've done here. I've just given the application of predict function. Let's see. Regressor.predict. When value of x is given as 8, what will be the value of y? This one. Now let's print it. 49 is the output. That's how prediction can be done. Now onwards we can predict the value of y for any value of x as input given there. Here one small example I mentioned. I'm taking this number of hours from user. Check. For example 10. I'm taking it. Hours will be 10 now. 10. Okay. And then I'm creating the value of new value of y based on this. See, just created this regressor coefficient into hours plus intercept, and we'll get this value of EQ 58.46. and if you use the same values here in the prediction, for example 10, and print the value of y plate, see exactly same value will get there. This is we are generated by using the prediction function. This value we are generated with the help of the regression's original equation. So this is what your output is. This is the equation that we form from this value of coefficient and intercept that we have already seen. Okay, and if you have to plot it, so we'll be using the plot function to do. Check x, y, o, original values are plotted as a dot, and the predicted values, expected values for the given data of x, or given as second parameter regressor.predict x, it will show a line on it. See, this line will show the predicted values, respected values. Actually, these are the original values, x and y. This is what your score is, and this is the input I was spent based on that. This is not actually linear. See how much distance the original values and the expected values is there. That's why the accuracy that we got is 43% here. So 43% is too much bad accuracy here. At least 80% accuracy should be available for your given data set. Then only it will be considered as a best algorithm to fit on the given data. We'll close this. Now a small change I have done here. I just modified my data set. You can check this to make it more linear. Okay, 10, 15, 9, 49 to 10. Okay, this one, and I will use this data set as input to it. Its name is hours.csv, and I'll run the file completely now. Check this. Now, correct. That's why I got accuracy 93.62%. This value is predicted values when value of x is given as 8. Number of hours I'm putting, for example, again 10, and get this equation. See, the value of intercept, value of coefficient, and rest score when value of 10 is given 84.76 here. And this is my, see, you can see, check these values are come closer again to the line. These are the expected values, these are the original values. So that's why, so 93% accuracy I'm getting from this particular code. Okay, so that's how a simple linear relationships that we can create. These are some useful resources that we can use, or you can log on to mitu.co.in on various sites, Facebook, our original site, Twitter, LinkedIn, or you can contact on these mail IDs if any doubts are there. Thank you.